Hello there. You join us live here for the launch of 3 satellites tonight from the Guiana Space Centre, which is in South America. We've got 2 telecommunications satellites waiting on the pad and also 1 mission extension vehicle. Now, if you're a bit curious to know what that is, then you're in the right place, because we're going to be finding out about the satellites tonight in the next hour. We'll also be watching the launch, of course, and we'll be following their journey through space. We've got lots of experts lined up for you tonight, and one of them is this man, Stefan Israel.
Hello,
Stefan, thanks for joining us. Stefan is the CEO of Arianespace, and which makes you perfectly placed to tell us about what's happening tonight. Stefan, first of all, let's take a look. We can see on our screens the launcher is on the pad, looking pretty good there. We've got a few clouds in the sky, though, tonight, haven't we?
Yes, but the launcher is on the launch pad. It has been transferred yesterday and everything is okay. We are now making the final operations, and as always, we are going to monitor the weather and to check the clouds, yes.
So we've got 3 customers tonight, as we said, and, sorry, 2 customers, but 3 satellites. So tell us about that.
Yes, so tonight we have Intelsat with Galaxy 30, and you know Intelsat is a very long-lasting friend of Arianespace. The first Intelsat satellite was launched in 1983, and tonight we are launching the 62nd satellite for Intelsat. We have another very old friend, which is BSAT, a Japanese operator. This will be the 10th satellite we will launch tonight for BSAT, and our relationship has started in 1997. And we have a newcomer, Space Logistics LLC, which is a subsidiary of Northrop Grumman. Northrop Grumman has built MEV-2 and in the Galaxy 30. Maxar has built the satellite of the Japanese operator. And this is a new vehicle tonight because this is a mission extension vehicle for in-orbit servicing. So we are very happy of this innovative mission.
It's exciting, isn't it?
Very exciting.
So we'll be finding out more about it later in the programme. But let's just talk about the situation we're in at the moment. Obviously, it's very complex, launching satellites during a global pandemic.
Yes, for sure. So you know that we are now in the context of a pandemic of the COVID, which is in all South America. And it is clear that this is the case in Guyana. We have taken all health measures to make sure that all our teams, the teams of our partners, of our customers, are working by respecting very strictly the new health conditions. And this is the case tonight in Guyana. And I really want to thank the team for the fact that they have delivered in such a difficult situation.
And of course, our thoughts and our support to everybody
yes.
in French Guiana who's struggling with this right now. Let's just go back to Ariane 5, our launch vehicle, because she's incredibly powerful. You launched several launches from the spaceport. She's the most powerful one, and she's becoming even more powerful, isn't she?
Yes, tonight it is the most powerful Ariane 5 we have ever launched. We have a capability of 10.2 tons for the satellites, and it is due to a program we have made with our parent company and prime contractor Ariane Group. Since 2016, we have increased by 300 kilos the performance for the satellite by diminishing the mass of the launcher. So tonight it is the most powerful Ariane which will fly.
Well, that's good to know. Well, Stefan normally is with us in French Guiana, heading up a very important group of people called the Flight Directorate. But of course, we're here in Paris, and Stefan, we're lucky to have you with us, actually. But we can go over, let's hope, now to the Guiana Space Centre, because tonight Luce Fabregat is there, heading up the Flight Directorate.
Good afternoon and welcome to Astra
Luce,
Society's
what is the
coverage of
Flight Directorate?
VA253 mission. This mission is going to be launching on an Ariane
Hello,
5
Katie. Yes,
here in
very
just
pleased.
about 25 minutes. Tonight, Arianespace is launching 3 satellites to geostationary transfer orbit. This is the most number of satellites they have launched to geostationary transfer orbit, which is super exciting. Bring you more detail on that and the launcher here momentarily. So some stats for this mission. This is going to be, let me find this, 109th mission for the Ariane 5 and the 280th mission for Arianespace. And it's going to be the 60th orbital launch attempt in 2020. Orbital parameters for this mission are a 250-kilometer perigee and a 35,780-kilometer apogee, that is 155 miles, and 22,206 miles for those of us who are metrically impaired. The payloads tonight are the Galaxy 30 satellite for Intelsat, the Mission Extension Vehicle 2 for Space Logics LLC, and BSAT-4B for Maxar Technologies. Galaxy 30 and BSAT-4B are both telecommunications satellites, with BSAT-4B being mostly for television services. The Mission Extension Vehicle 2 is a vehicle which will maneuver towards a satellite, hook up to it, and extend its operational life. Not sure which satellite it's going to yet. I'll get that in a moment. So the total mass for this mission is 9.7 metric tons to geostationary transfer orbit. This is not the heaviest mission that the Ariane 5 has launched. However, it is a very, very hard mission to do, and I'm super excited to see this launch tonight. So about the Ariane 5. This is the Ariane 5 ECA. We will explain the difference and what ECA means later. So the ECA is currently the only operating variant of the Ariane 5, and the ECA has been launched for some of the longest times. The ECA's limit to geostationary transfer orbit is about 10.8 tons, give or take, and so we are well within mission parameters. Many Ariane 5 missions are, as we mentioned, ride shares, meaning multiple satellites are launched on one single rocket. The Ariane 5 is manufactured and operated by Arianespace, which is a French company that has been manufacturing launchers for quite some time. One important note is liftoff does not actually occur at T-0. This is actually a countdown to when the Vulcan main engine on the Ariane 5 will ignite, and it will come up to full thrust over just about 7 seconds, and liftoff will occur at T plus 7 seconds. First stage of the Ariane 5 consists of the EPC main stage and the Vulcan 2 main engine. This stage uses cryogenic liquid hydrogen and liquid oxygen and is approximately 31 meters tall or 102 feet. The two boosters are two P-241 solid rocket boosters. Each is 31.6 meters tall, which is actually slightly larger than the first stage. The two boosters can be recovered via parachute. However, this has only been done once, and they were not reused like the Space Shuttle boosters were. The second stage is the ESC-D upper stage, which with an HM-7B engine. This is cryogenic and hydrogen and liquid oxygen stage, and is only about 4.71 meters tall. So it's actually a very, very short stage, but it's very wide, so it contains a lot of fuel. This engine is capable of multiple restarts, however, that will not be required for the mission today. Coming back to the ECA variants of the Ariane 5, ECA is the current operating version, which uses the hydrogen stage. However, the non-ECA variants, such as the G, GS, and G+, use the old EPS hypergolic stage. Coming back, we have a question in chat. What fuel are the SRBs running on? P-band? I do believe it is P-band, but I will check on that.
You can see there people wearing specific suits because of the dangerousness of the activity. In parallel, BSAT-4B was also filled with propellant in another building called S4. After filling, the next operation is what we call...
No, actually, oh wait.
...that we attach the spacecraft onto...
No, the boosters actually do not use P-band. They actually use HTPB and aluminum trimethyl bore and all that stuff, according to Wikipedia, from what I can tell. So, wouldn't super count on that. So again, if any of you have questions, feel free to leave them in the chat and we will answer those for you. So our mission timeline for tonight, at T-minus 7 minutes, the synchronized sequence starts. This means the launcher will be synchronized and get ready for flight. At T-minus 4 minutes, tank pressurization begins, meaning tanks are pressurized to flight levels. At T-minus 1 minute, the launcher and satellites transition to internal power. At T plus 1 second, the Vulcan 2 main engine will ignite and come up to thrust for the next 6 seconds. At T plus 7 seconds, SRBs ignite and the launcher lifts off the launch pad. At 2 minutes and 22 seconds into flight, the solid rocket boosters jettison. At T plus 3 minutes and 20 seconds, the fairings jettison. And this core stage burns liquid hydrogen and liquid oxygen, so it is actually a very super efficient engine. This means that it consumes fuel at a very slow rate, meaning the first stage burns for almost 8.5 minutes. So at T plus 8 minutes and 40 seconds, we will have first stage engine cutoff, and 6 seconds later we will have stage separation. With 4 seconds later, the engine will ignite on the second stage. The second stage engine is also a very super efficient liquid hydrogen and liquid oxygen engine, meaning this burn will last almost, looks like 17 minutes for the second stage burn. This will not, however, be putting it into a parking orbit. Rather, this will be direct to geostationary transfer orbit, meaning there will not be a coast phase and a restart. After second stage engine cutoff at T plus 25 minutes and 52 seconds, we will have satellite deploy. So first the Galaxy 30 satellite will deploy, then the Mission Extension Vehicle 2 will deploy. After this, there will be a small coast phase to allow these two satellites to distance themselves from the launcher. Before BSat 4B deploys at T plus 47 minutes and 39 seconds, the shroud, which covers the satellite during launch, will be jettisoned and allowed time to coast away. Once that is complete, BSat 4B will deploy. So the launch window opens at UTC 2130 on July 31st, 2020, which is today, currently 17 minutes from now. If for whatever reason, if for whatever reason there is a hold, launch window is about 40 minutes long, so we will get back to you if that happens. Mission duration tonight should be just over 48 minutes. So for now, let's listen into the commentary provided by Ariane Space.
She's going to take off in just under, just under an hour to deliver our satellites. And so let's just have a look now at what's going to happen once she lifts off and how she's going to do that.
The booster ignition will trigger the liftoff of the launch vehicle. Shortly after the liftoff, the launcher will perform a pitch maneuver in order to get in the right direction. The booster separation will occur slightly more than 2 minutes after liftoff. Just after, we will separate the fairing as well. The main engine switches off when the intermediate orbit is reached. This event is called injection into orbit. Just after, the main stage is separated and will fall down into the Atlantic Ocean. The upper stage is ignited and it will carry our passengers up to the geostationary transfer orbit. During that flight, we have still the effect of the atmosphere, even if thin, because we fly very fast. This is the aerothermal flux. Upper stage switches off when we have reached the orbit. This is the beginning of the ballistic phase when we can separate all the spacecraft. First of all, Galaxy 30, then MEV2 separation. Before separating the BSat 4B, we separate the SILDA. And finally, BSat 4B, our last passenger. The launch vehicle mission is not completed yet because it will start the passivation. After that moment, the Mission Control Center team will take over and the spacecraft team will make all the job to get the satellite up to their final journey.
Indeed, and of course, Galaxy 30 and BSat 4B will travel on their own to their final destination, which they have their own slot in space, and they'll be going to that slot. But MEV-2 is different, isn't it?
Completely different, because it will dock to another satellite, which is a customer of MEV-2 to extend its lifetime.
So it's actually going to dock with another satellite, and then it's going to push it a little bit, use its own thrusters, and raise its orbit.
All the maneuvers, yeah.
Yeah, it's really, really exciting technology. Now, we have two control centres working on the launch over in French Guiana. We've got the Mission Control Centre, which we've been looking at. But we also have another one. It's called Launch Control, and it's closer to the pad. It's about, I think, about 3 kilometres away. There it is. It's actually a concrete blockhouse, isn't it, Damien?
Yes, it is, and it is completely airtight at the end of the chronology in order to protect the people. We have there basically two teams, one which is the operational team who is responsible for the final operation before liftoff, and another one with the flight worthiness team who is in charge of checking the flight worthiness and last status of the launcher. This latest team is led by Guillaume Galato, the LSTO, whereas the operational team was led by the LCOM, Patrick Lucet, that we have seen at the beginning of the movie. And you can see there people working inside the CDL.
So that's the Launch Control Centre there in French Guiana, but there is actually another one in France, in Europe, and it's called Space Code. It's an exact replica, so all the launch controllers in Europe can see exactly what the launch controllers can see in French Guiana. Let's find out a little bit more now about how it works and the reasons for it.
And we are back, so we do have some more information for you guys too. So we have some information on the mission extension vehicle. So the mission extension vehicle will be joining Intelsat 1002. This was a satellite launched in 2004 on a Proton rocket from Russia. This satellite occupies the 1 degree west mark over South America, Africa, Europe, and the Middle East. Yes, so we do have a question in chat. The French Guiana Space Centre is located near the equator. So why aren't there more launch sites near the equator? Well, that's a very good question. So unfortunately, there aren't many space powers located near the equator. So the closest is France. Now, you would usually think of France as a country in Europe, which is pretty far from the equator. Well, France actually has territory coverage over French Guiana, which is actually part of the country of France. So they were able to build a launch center there, which is very important because if you're launching from the equator versus, let's say, 45 degrees north, where Russia is, you have a very, let's say, how do I say this? So the Earth rotates. And if you're closer to the equator, you are rotating faster around the Earth's center. So you actually get more of a quote-unquote boost when launching from the equator. So this is super important for launches such as geostationary missions, where you have to have an orbit that is at 0 degrees inclination, meaning it does not go above or below the equator in space. However, this can be very detrimental to polar orbits, or orbits that go over the Earth's poles. So if you want to orbit over the poles, you have to have a launch. You don't have to have a launch site that is further from the equator. But if you're further from the equator, you don't have to cancel out Earth's rotation as much. So that's a very good question. Again, if you have more questions, feel free to leave them in chat and we will answer those for you. So we are just coming up on the T-minus 10-minute mark for launch. Again, launch doesn't actually occur at T-minus 0, rather ignition of the Vulcan 2 engine occurs at T-minus 0. Liftoff actually occurs at T plus 7 seconds if all things go well.
So hello everybody, I'm
Again,
very
the
pleased to be
Ariane
here
5
with...
is fueled by liquid oxygen and liquid hydrogen on the first and second stages, with the boosters utilizing solid propellant.
to prepare
There are 2 boosters, each are 31.6 meters tall.
transition note where
So the boosters will not be recovered tonight. However, it is possible if they really wanted to. On the first successful Ariane 5 mission, the boosters were recovered via parachute and landed in the Atlantic Ocean and were brought back to land. However, they were not reused like the Space Shuttle SRBs were. Oh, okay. So it was only one of them was recovered.
Interesting, huh?
Completely, yes.
Two complete replicas. So the final countdown started about 11 hours ago. We're now 8 minutes and 37 seconds to launch, getting towards the end of that final countdown. What's been happening?
The teams have been completed the operation since this morning. Mainly the operation were checking the electrical connection between the different elements, flushing and cooling the feeding lines so that we can fill the tanks with propellant, activating the equipment on board the launcher, one after the other, to check the status. And we are doing this in order to be able to check that everything is working perfectly before we enter the synchronized sequence.
And here we can see the teams in French Guiana, the program director's desk. What are these guys doing? And there's the Jean-Christophe Delaunay, who is the
mission director.
And we can see here the status panels, and this is the range operations manager.
Yes. The range operation manager is the one that is coordinating all the activities on the basis and which receives all the information from different elements.
And he's the one who's going to be calling out all the important milestones because, of course, there are lots of buildings across the base. Yes. And everybody has to listen to the range operations manager to get confirmations of the main events. He's about to call one out now.
À tous de DDO, attention pour la séquence finale lanceur.
So he has announced the beginning of the synchronized sequence. It's the last 7 minutes in the countdown. And this is the time now when really the computers are starting to take on the job, aren't they, Damien? What's happening?
The synchronized sequence.
And we are back. So we have passed the T-minus 7 minute count, and we are inside terminal. We are not inside terminal count, however, we are approaching terminal count. So the synchronized sequence has started on the launch vehicle and is being synced and prepped for liftoff. Fueling is currently underway and will be completed just before liftoff. Tank pressurization is the next event and is coming up at T-minus 4 minutes. Currently, weather is go. Everything is green on the board. We are go for launch of the Ariane 5.
Come to see us here in the studio. Raphael, thank you very much indeed for being with us. You tell us your job and what you do, Raphael, for Arianespace.
Basically, I'm a business developer.
So again, Ariane is launching 3 satellites to geostationary transfer orbit. Now, people just throw around orbit names, but they don't explain them. So let's explain what geostationary orbit is. So geostationary orbit is when you are orbiting around the Earth and you do not move relative to the surface of Earth. You stay in the same position over the Earth. So normally if you see videos from, let's say, the International Space Station, you can see that it is booking it across the Earth going super, super fast around. This is not the case when you're up at geostationary orbit. When you're at geostationary orbit, if you look down at the Earth and kept looking, you would actually move with the rotation of the Earth. Now, this is not where the launcher is putting the satellites tonight. The launcher is actually putting the satellites in geostationary transfer orbit, meaning its apogee, or its distance which is furthest away from the Earth, is located at the point of geostationary orbit, but the perigee, or its location on the orbit closest to Earth, is right above the Earth's surface. So it is up to the individual satellites to inject themselves into the proper orbit after being separated from the launch vehicle. Direct to geostationary orbit services are offered by launch companies. However, this takes a substantial payload penalty due to the increased energy required for these missions. We're coming up on the T-minus 4 minute mark. Tank pressurization has begun on the launch vehicle. Next event is transition to internal power at T-minus 1 minute.
For before we come up to the launch, we are right now 3 minutes and 22 seconds. If we take a look at our launcher on the pad, if we have an image of that, we can see the skies looking pretty reasonably clear.
So we do have a question in chat. Where is geostationary orbit, or how high above the sun? Well, unfortunately, the sun does not have a solid surface, meaning that it is actually impossible to be, quote unquote, geostationary, meaning you're always above the exact same point on the sun. But let's say the sun did have a surface and was the same around. So the sun actually rotates around itself, I believe, about every 30 days. Hold on, let me look this up. Yes, so at the equator of the sun, it rotates once every 24.5 days. So Mercury, in its orbit, actually rotates once every, I believe, 53 days. Oh, we are under the T-minus 2 minute mark. So actually, geostationary orbit would be much inside the orbit of even Mercury, meaning it would be super, super, super hot. And it looks like Ariane has removed their countdown. So we are going to, and it looks like some systems have transitioned to red. We might have had a delay.
That means that we need to stop. Damien, just to talk us through what the range operations manager just said.
This red corresponds to a red coming from the launch base. However, everybody is still keeping ready.
So unfortunately, as the launch commentators are saying, we have a panel that has transitioned to red. We will give you more information on this, but it looks like we are in a hold or scrub at the moment.
We go for liftoff. So we are currently treating this anomaly, and we will come back when we will have more information about that.
So the chronology is continuing for the moment. The chronology, or what we call in English the countdown, and as you say, Damien,
so as the launch commentators
system
are
is
saying,
absolutely made for this. So
this
red
is
status
perfectly
panel
normal.
is a perfectly
you
normal
want
thing to
be
happen
in a hold
because
rather
it's
than
flagging up
go
a glitch that we need to fix, and once we can get that sorted out,
as
then
the great
hopefully we'll
everyday
be able to
astronaut
launch.
says,
Now,
holds are better than booms.
let's just see whether we can have another closer look at our status panels so that we can have a look and see the red status panel that has turned red. Yeah, no, maybe we can't see that right now, but I'm sure we will in just 1 second. So we have a
So when a
launch window.
panel on the board is red, this does not mean there is something inherently wrong with the launch vehicle. This means a configuration might be wrong, or the weather could be transitioned to a state where it is not acceptable for launch, or in the most simple of times, a boat could have come into the launch hazard area. So there are many, many factors that have to be taken into consideration when launching a rocket. And unfortunately, if one is red, you cannot launch. So we will listen in on the launch commentators here to try to get some information.
There can be different constraints of illuminations, of energy on the solar panels for the spacecraft after separations. So we are putting all these constraints together in order to build what we call the launch window, which is the time during which we fulfill all the constraints for the customer from the launch base and from the launcher. And for today, it's more than 40 minutes. So we have still time in order to be ready for liftoff later on.
And what's everybody doing now? Because as you remember, we've got the several different control centres. We've got the Mission Control Centre, which we've been looking at, the Nerve Centre, really, where Luce and Bruno are sitting and the other teams. We also saw the Launch Control Centre, where the teams are concerned primarily with the launch vehicle and the launch pad. What's everybody doing now in a situation like this?
It's depending on the issue that is being treated, of course, but all the teams that are involved in the technical field covered by the issue or the points to be resolved is working currently on the topic with the help of all technical teams which are located in Europe or directly in French Guiana in order to help solving the issue as quick as possible. And one other important point for this mission is we spoke about the launch window, but we have quite a kind of particularity for this mission because the launch window is split into two sub-launch windows because we check, of course, all constraints, as I told you, and one of the constraints that we have to check is that we have no risk of collision with the ISS, which is a really important
Yes, so
criteria.
let's just talk about that in a little bit more detail. Maybe you could explain to us what the ISS actually is, the International Space Station.
International Space Station is like one of the major projects that's been built in space, and it actually is a good example of cooperation in space because there are lots of space agencies, national agencies that are implicated there. And of course, you know that our national hero, Thomas Pesquet, went there once, and he will go back there.
I'm just going to remind everybody that Thomas Pesquet is the French astronaut who lifted off to the International Space Station 2 years ago?
About 2 years ago.
About 2 years ago.
Yeah.
And just a quick interlude, because I was actually doing the commentary during that launch, and it was a very wonderful moment.
And we are back with more information. So it appears to be some sort of issue with the ground surface equipment, which links the rocket to the launch pad. Unfortunately, GSE issues means that it is likely a scrub for tonight. We will continue listening in on the count to try to figure out if they will or will not launch tonight. So unfortunately, it does look like we could be in a scrub, but we will let you guys know.
Technologies in space. I want to remind that the International Space Station is within the area where the magnetic field of the Earth is still protecting astronauts from radiations from space. So it's quite like a safe place to work there. And so you can test technologies, you can run very complex experiments, and especially experiment in zero gravity conditions, so it's very valuable. You do some repair of the station. The station has been growing more and more with the time. And so, yeah, there are lots of stuff that are happening there. And the International Space Station is going to be running for a few more years. And then the national agencies are right now thinking of a new way to continue this kind of cooperation. And the main idea right now for them is to actually do an International Space Station around the moon. So the challenges are much more strong and difficult because there you don't have the magnetic field of the Earth to protect the astronauts. So you have to test strong technologies to protect from the radiations from space, etc. It's like 380,000 kilometers from Earth, the moon. So it's a much longer way to go there. So it's a very, very exciting space decade that's coming.
It's huge, isn't it? It's absolutely remarkable, and you guys are involved in it, and it is very exciting. Now, I think we're going to take a break. The countdown is on hold. As we've said, we have a launch window, so we're going to wait now and come off air just for a while and get a little bit more information, and we'll come back to you. In the meantime, do keep your eye on the website, arianespace.com, and we'll come back to you when we have more information. But for now, see you shortly.
Rouge sauvegarde. vers sauvegarde. à tous de DDO. Arrêt de la chronologie, arrêt de la tentative de lancement aujourd'hui. La chronologie est définitivement donc arrêtée aujourd'hui. Elle sera reconduite demain avec un H0 visé à 18h30 local, à 21h30 TU. Que tous les moyens restent activés pour une mise en configuration d'arrêt de la base de lancement.